Hi, this is Ms. Fitzmaurice, and this video is the solution to the second practice quiz for graphical motion. Okay, so in our first problem, we have velocity time graphs. Okay, always look at what kind of graph you have, and it asks which particle is furthest from the origin at t equals 2 seconds. Okay, so I'm going to go ahead and think about our XVA. Okay, if we're going in this direction, we use slope. The other direction, we're going to use area. Okay, so we have velocity graph in this situation, and it wants to know about furthest. Okay, so we're going to position. That means we need to think about area. Okay, so it's asking which has the biggest area after 2 seconds. Okay, and actually, which one has the biggest absolute value of area? We can actually calculate it. So we have, in our first case, a triangle and 1/2 base height, so we have 1/2, the base is 2, and the height is 1, so that gives us an area of 1. Okay, in the second case, it's a rectangle, so it's base times height. Our base is 2, and the height is 0.5, so again, we get an area of 1. Okay, in our third particle, so particle C, we have 2 rectangles. One is positive and one is negative. We can see that they're the same size. Okay, this one is base times height, so that's positive 1. This is negative 1, and when I add them together, I get 0. Okay. Particle D, we can't calculate the exact area, but we can visually see that it's smaller than A, so we know that it's less than 1. And then for particle E, we just have one rectangle. Again, it's a rectangle, so base times height. Our base is 2, our height is negative 1. Okay, but we get 2 meters. We're just looking for the furthest away. Since we are negative 2 meters away, that is the furthest, and our answer is option E. Alright, so number 2 is asking us about the same graphs as we had in number 1, and it's asking which particle moves with a constant non-zero acceleration. Okay, so we can look at these, okay, and we should know that in general, if we have a velocity graph, which we do, and we are wondering about acceleration, we use slope. Okay, so if the acceleration is constant and non-zero, what we're looking for is a constant slope that's not equal to 0. Okay, and it looks like in A we have a constant slope that's not 0. In B, our slope equals 0. Okay, our rise over run is 0. Okay, in C we do not have a constant slope. We don't have a constant slope in D, or in E, we again have a 0 slope, so A is the only option where we have V and T, and our slope is constant but not equal to 0. Okay, so number 2 was option A. Alright, so let's look at number 3. It says above is a velocity time graph representing a duck flying south for the winter. At what point does the duck stop its forward motion? Okay, so we know that if it's stopping its motion, v equals 0. Okay, we look over here, we have a velocity graph, so it's asking where is our graph equal to 0? Okay, at point A, our velocity is positive, B, our velocity is again positive, C, again, the velocity is positive, but at D, our velocity is 0, the duck is stopped, and so it is only at point D. Okay, all of these other places you might be tempted at B or C to say that the duck is stopped because the slope is 0, that means acceleration is 0. Okay, so for number 4, we can move this up. Okay, it says a child left her home and started walking at a constant velocity. After a time, she stopped for a while and then continued on with a velocity greater than she originally had. All of a sudden, she turned around and walked quickly home. Okay, which of these best represents a distance versus time graph for her walk? Okay, so we know that she walked first at a constant velocity. So, first of all, we're talking about a distance time graph. Okay, so if she's first walking at a constant velocity, that means a constant slope. And as you take the test tomorrow, it might help you to annotate like this. After a time, she stopped. Okay, if she stopped, that means slope equals 0. And walked very quickly back home. Okay, so if she walked very quickly back home, that means the velocity is going to be negative and steep. Okay, so she's walking along at a constant velocity. She stops, she walks faster, she stops, and then she goes home. That matches C, okay, because we had a constant slope, we stopped, continued with a greater velocity, so this was a bigger slope, turned around, this is where she turned around and went quickly back home. Alright, so for number 5, we have the same picture as we had before. Okay, and it says, at time t equals 0, car X travels with a speed of v0, passes car Y, which is just starting to move. Both cars then travel on 2 parallel lanes in the same straight road. The graphs of speed versus t, so we have a velocity time graph, are shown above. Okay, and our question is asking from t equals 0 to t equals 40 seconds, the areas under each curve are equal. Okay, so what does that mean at t equals 40 seconds? Okay, I'm going to make our little chart as usual. So we have area and slope. Okay, if we know that the areas are equal, so this area, if I colored in that triangle, is equal to this area if I were to color in this rectangle. Okay, we have velocity. If we take area, that means we're finding the position. Okay, so what that means is that the position of car X, and I'm going to say X has to equal the position of car Y. So XX is equal to XY. Okay, so I'm going to read the options. Car A is behind car X. Y is passing X. Y is in front of X. Or X is accelerating excuse me, faster than Y. Okay, so we know that their positions are the same, okay, all throughout before t equals 40 seconds, this triangle has been smaller than the rectangle. So car Y has been behind car X. Okay, when they're equal, that is when Y will be passing X. Okay, so it's not that Y is in front of X, it's that at that very moment Y is passing X. Alright, for number 9, it asks, what is the displacement of the object between 2 and 4 seconds? Okay, so I have a velocity time graph, and I want displacement. Displacement corresponds with delta x. So I have x, v, a, and I'm going to make my little chart as usual. Slope, area, and I know that if I have velocity and I want acceleration, I have to go ahead and find the area. Okay, the area between 2 and 4 seconds will be this square or rectangle plus this triangle. Okay, so I have to find both and add them up. For the rectangle, the area is base times height. Okay, my base from 2 to 3 is 1, and the height is 2, so that area is equal to 2. For the triangle, I have 1/2 base times height. Okay, my base will be from 3 to 4, that is 1. The height is from 0 to 2, which is 2. Okay, and that will be equal to 1. When I add them together, I end up with 2 plus 1, which is 3 meters total, and that is answer C. Alright, so finally for number 10, it asks, what is the acceleration of the object at t equals 1 second? Okay, again, I'm going to look at my normal chart. XVA, slope, and area. Okay, I have velocity, so I have V. I want acceleration, so I have to find the slope, and I have to find it at 1 second. Okay, I can pick any 2 points along this line, so I'm going to pick easy ones. I'm going to pick this point right here and this point right here. Okay, the rise is 2, the run is 1. Okay, so my slope is going to be equal to rise over run, which is 2 over 1, and in this case 2 meters per second. Option C. Except that we have acceleration, so I shouldn't have done that. It's not option C, it is option A, 2 meters per second squared. Okay, so one thing you need to be careful on during the test, and I made that mistake on purpose because you might see something like this on the test, is you have to make sure that you have the right units. Okay, some of the multiple choice answers might be the correct numbers but the wrong units. So you really need to be careful of what your units are. Alright, so I hope this was helpful in reviewing. Good luck for tomorrow. Don't forget to make a flashcard.